Morning everyone. A very good morning. Shall we begin the session? Today's topic is operators in C++. How the operators used in C++, what is the usage of operators in C++, what kind of operators are used over here. I'm just giving an introduction about this, then take a break for 5 minutes. So C++ have a rich set of operators. There are so many operators that is all right. Now next part is a rich set of operators that must be introduced that must be enabled in the C++. So all the operators or all C operators are valid in C++ also. In addition to that, C++ introduces some new operators also. We have already seen two operators, such operators, for example, insertion operator and the extraction operator. We have seen insertion is that is used to display the information with the help of cout. Extraction means which extracts the data, which gives the data to the memory. Now, new operators or some other operators are scope resolution operator that is used to fetch the global variables, then pointer to member declarator. That means with the use of scope resolution, we use the asterisk sign, we use the pointer sign, then pointer to the member operator, arrow sign, asterisk, then pointer to the member operator. That again, it is also used with the dot and the asterisk. So either it is used with the arrow and the asterisk, dot and the asterisk. Then delete memory release operator that is also used for deleting the content, deleting the memory. Then endl line feed operator. For making the next line. Then new, that is the memory allocation operator. So new and the delete. New is used for memory allocation, delete is used for deallocate the memory. Then set w, that is a field width operator. In addition to that, C++ also allows up to two new modifications of some of the built-in operator, that is give the certain meanings to an operator that depends on the type of arguments we are used. This process is known as operator overloading. That means more than one operators are used at the same time. That is the same operator. That is known as operator overloading. Overload the operator. And the next is the scope resolution operator. So like C is also a block control language. So blocks and the scopes can be used in constructing the programs. And we know that the same variable name can be used to have different meaning in the different block. That is, more than one blocks are used with the same variable name that have a different meaning. And the scope of the variables extend from the point of declaration till the end of the block containing the declaration. So whatever the declaration they have, whatever the block they have, their declaration will be used within that block only, within that declaration only. And that declared inside a block is also set to local to that block. Now this is again the next example, that is a dot 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 int x equals to 10, then dot dot dot, then int x equals to 1, dot dot dot. So these two declaration of x refers to two different memory location containing different values that must be available, that must be used within that block only. And these two declarations are used as a profile. Now the next part is a declaration of the x that refers to the two different locations, that refers to the two different memory locations that contains different values also. So statement in the second block refers to the variable x declared in the first block and the vice versa. So blocks in the C++ are often not nested out, and this will be used with the different styles, with the different scenarios. So dot 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 int x equals to 10, int x equals to 1, block 1, block 2. So block 2 is contained in the block 1, and declaration is also used as the inner block that hides a declaration of the same variable in an outer block. So that is, each declaration will cost refers to the different data object, different data values within inner block. The variable also refers to the data value or data object that is declared therein. So in this case, the global versions of the variable cannot be accessed from within the inner block. So we are using the scope resolution operator to fetch the that we can say the global variables, global values. This can be used to uncover a hidden variable that takes the following form: variable name. And this operator also allows the global version of the variable that can be used. This can be used to make the count version of the global versions of the variable, that is count. So that to make the local variable count declared in the that block. So the scope resolution operator will be used with this one. We are declaring the global variable, that is the int m equals to 0. Now see, there is a difference between the two values. M has a value 10 in the global scope. M has a value 20 in the inner scope. So this 20 will be contained within that block, that is the int main block only. But if I want to access a 10 value, how we can access? By using the scope resolution operator. Yeah, very good. So if I print m, only m within the int main, so it will give the value always as a 20. Or if I give any operations, that may be m plus 20, m plus 2, so that takes a value as a 20 because it is inner, that is declared local to the main. But if I need 10, what will I do? That is the next question. So that next question answers will be given within the scope resolution operator. So m equals to 20, k equals to m equals to 30. So m declared again local to the inner block. So we are in the inner block, k, m, then scope resolution operator m. So first of all, there is a value of m that is contained, that is we can say stored in the k. So k has a value 30, m has a value 30. Then scope resolution m. That means we give the value as a 10 of the scope resolution. Yes. Within the inner block also we can refer the global variable. It is not mandatory that global variable are accessed outside the int main. No, it is also accessible within the int main. Now after int main there is a, yeah, we are in the outer block m, then modulus scope resolution m. Again there is a 20 and the 10. So there are two values, 20, k 20, m 30. Yeah, k 20, m 30, m 10, again m 20 and m 10. So they are using the dereferencing operator with the various types of the data and the function, that is also again done with the use of the pointers. That will be accessed within that block only. Now next part is a member differencing operator, that is again it is used within that block. Again it is used within the member referencing. So C++ permits us to define a class containing various type of data in the function as a member. So C++ also permits to access the class member through the pointer. Till now we have discussed with the scope resolution only using the global variable. Now if I want to access the class member with the pointer, so that will be achieved with a 3 pointer to the member operators. There are 3 pointer to member operator that is given. So declare a pointer to a member of the class, to access a member using object name and the pointer, to access a member using a pointer to the object and pointer to that member only. These are given with a pointer to the member operator that will be allowed with the classes, that will be allowed with the member differencing operators that will be used. Now, let's see what are the usage of these one. So to declare a pointer to a member of a class, we use the scope resolution and the asterisk. So to access a member using object name and a pointer to that member, we use only the asterisk. To access a member using a pointer, we use the arrow and the asterisk. Yes. Now the next part is the memory management operators. Same, malloc and the calloc. Yeah, free also. Let's see what are the various memory management operators we are using out in C++. So C uses malloc and calloc to dynamically allocate. What is the meaning of dynamically allocate and the statically allocate? So C uses two functions, that is the malloc and the calloc, to allocate the memory dynamically at the runtime. Similarly, it also uses the function free to pre-dynamically allocated memory. So malloc and the calloc is used to allocate the memory, and the free used to deallocate or free the memory. So we use the dynamic allocation techniques, that is non-advanced. Now, what C++ supports? C++ supports only two functions, new and the delete. Instead of malloc and the calloc, new will be used to allocate the memory, and for reallocating the memory, delete will be used. Now this is the syntax how it will be used. So this is the pointer variable equals to new data type. So this new operator can be used to create the objects of any type that can take the following general form. Now next part is a pointer variable equals to new data type. That means whatever the variable we use equals to new data type. For example, if I created out the p equals to new int, so new will be allocating the memory for the integer. Now what is the integer? That contains a variable p. So that's why it is used p equals to new int. So this new operator allocates the sufficient memory to hold a data object of any data type and returns the address of the object. This data type can be of any valid data type, and this pointer variable holds the address of the memory space allocated. Now example includes p equals to new int, q equals to new float, where p is a pointer of the type int and q is a pointer of the type float, where p and q must have already been declared as a pointer of the appropriate type that will combine with the declaration of the pointers and their assignments. This is the int pointer p, new int, float pointer q, new float. Subsequently, the statement pointer p is 25. In the same way, pointer q is 7.5. That would be allocating the memory. Yes, just wait. Another form to initialize a memory with using the new operator, that is a pointer variable new data type value. Int pointer p equals to new int 25. Float pointer q, new float 7.5. Yeah, both the values, both the options are correct, but in this it is pointer p or the q that is using the value 25, that is of the integer type, and the new. And as mentioned earlier, new can be used to create a memory space for any data type that includes the user-defined types such as the arrays, structures, and the classes. The general form is pointer variable new data type size. This can be used to specify the size within the elements, number of elements in the array. So int pointer p equals to new int 10. That means p is a pointer that will be creating the new, that will be taking the integer of the 10 values. So this creates a memory space for an array of 10 integers where p0 refers to the first and so on to the second. Now when creating a multidimensional array, With the new, all the array sizes must be supplied. So array pointer is new 354, 3M54, 35 dash dash M54. Dimensions will be given or has to be given. Next is the delete, then pointer variable. That is destroyed to release the memory space for the reuse. And general form is given as the delete pointer variable. That is a pointer that points to a data object created with the new. Example, delete P, delete Q. If I want to free dynamically allocated array, we must use the following form of delete. There is a delete size pointer variable. For example, int 10a or P. What is the meaning of delete 10p or delete int 10p? That means we are using with this one. Now this is the delete pointer or array P. Will delete the entire array pointed to a P. What happened if the sufficient memory is not available for the allocation? In such cases, the delete pointer, the delete will be used. The delete array will be used, or malloc or the new returns a null pointer. Therefore, it is a good idea to check for the pointer produced by the new before using it. So that will be done as follows: p equals to new int. If not p, cout allocation failed. Now, new operator have some advantages, that is against the malloc.